How to make a pendulum wave. So the period of a pendulum is determined by its length in a uniform gravitational field. That naturally determines its frequency. Imagine a series of pendulums, different lengths. They'll have different frequencies of oscillation. If you line them all up in a row and release them, let's say from the left, they'll be in different places at different times. They make cool wave effects, and on occasion, they're in the same place at the same time where they started. So that desired effect is a good jumping off point for making a pendulum wave. We choose a time when we want that to happen, all pendulums back to the left. We will need a whole number of oscillations for every pendulum bob to be completed at that time, 60 seconds. So a bad example would be a pendulum bob completing 20 and a half oscillations in 60 seconds would put it all the way to the right, or halfway through an oscillation at the 60-second mark. Not desired. So we might also have some physical spatial constraints. Let's say we only have a meter to work with per pendulum. That would put our max pendulum length at a meter. So we start with that number, plug it into the pendulum frequency equation. We get 0.4982 hertz. If we multiply that by 60 seconds, that's 29.89 oscillations in 1 minute, which is not an even whole number. So that would not put the pendulum exactly at its leftmost point at the 60-second mark, but it gives us a good starting point. And if we go to 30 oscillations per second, it's a number close to 29.8. It should be a pendulum slightly shorter. It is a whole number, and it is a frequency of 0.5 hertz. If we solve that frequency equation for pendulum length now, we can plug that 0.5 hertz frequency in, 9.8 meters per second squared gravitational field, and we get a pendulum length of 0.993 meters or 99.3 centimeters. So that's our longest pendulum. Now, if we require our next pendulum to complete 31 oscillations in 60 seconds, that gives us a different frequency, and that gives us a different pendulum length, 93.0 centimeters. So carry that trend on, 32 oscillations for the next shortest one, so on and so forth, as many as you can fit in your apparatus, and you'll get cool wave effects, as long as you're careful to be consistent in how you measure pendulum length from axis of rotation to center of mass. Good luck.